Okay, good morning. This is how to do linear regressions on the calculator. These are the 6 steps. Okay, I'll walk through these 6 steps on the calculator as we go. So hopefully we can see these buttons. Okay. Alright, so then we're going to put these numbers in our sequence. Okay, so alright, here we go. Okay, so first off, we clear everything. So we take our calculator and we do second plus, turn it on for ourselves. So drop this up so you can see it better without the door. Okay, so these steps over here tell us what to do with these. Okay, so we're going to do second plus 712. Gets our thing cleared. Then we're going to just turn our R, so we're going to do these next steps. So you can get the mode key, it's right there, scroll down to stat diagnostics is right there, slide over and hit enter to turn the on. Okay, and from there we're going to enter our data. So we'll go to step 3. That's just step 3 is here. Okay, enter our data. So we're going to go back to stat program, which is right there. So stat. We're going to hit enter to edit this. We're going to put in our numbers. So our numbers are 62 or 67. Then hit enter. And 72 and 77 and 74. 69. You get the less 2 now, you just hit your side arrow key, put your left side, we do 155, 220, 240, 195, and 175. Take a minute right here and check your numbers, make sure you got them all right, because if you don't have good numbers, you'll get a bad answer. Okay, so our numbers are correct. Okay, and from there, we're going to step 4, which is to perform the regression. And so we go back to our stat key, and we overslide over to calc, and we go down to step 4, then regression, and we hit the enter until it does the calculations. Okay, so this right here is my equation they're talking about, y equals ax plus b. Normally we have an m there, so it's y equals mx plus b. So it's just a standard form of linear equation. And so my a number is 7.75, so we're going to put in, here we're going to write our equation. So writing our equation, we're going to put these numbers in here. Okay. So y equals 7.75. Then put our x. And our b number is minus 359.79. Okay, so there's our equation, and then our correlation coefficient is this bottom number right here. This bottom number is our correlation coefficient, so this is going to be 0.90. This is our correlation coefficient. Okay, then to finish this out, we're going to use our equation now. So we're going to take our equation, which is 7.75 times 80. I'm going to put this 80 in there right there. Okay, so times 80 minus 359.79, and that's how we get that 260.21. Okay, that's how we get that number there. Okay, so on the second example, okay, so same idea. On example 2, you get this in here, you do the same thing with this. Get my calculator back in spot here. Okay. And we're going to go back to those same 4 steps again. So you're on your paper now, so do the same steps. We're going to do clear everything, so second plus 712 clears everything. Go back to the mode button, and then go down and change your diagnostics on. Okay. And go back to your stat key. And we're going to do edit. We're going to put our numbers in edit. And so we'll do list ones. We've got 0, 5, 10, 15, 20, 25, and 30 on that side. On this side, we slide over with the key to list 2, put in 280, 410, 563, 739, 906, 1172, and 1639. Okay? And again, same thing, we'll do a linear regression now. So check our numbers. 5, 10, 15, 20, 25, 30, so 280, 410, 563, 739, 696, 1172. Okay, so we got our numbers. So we're going to do stat, calculate, number 4. Okay, again, go down to get this. So our equation is y equals 4.4642.46x plus 178.71. Our correlation coefficient is 0.97. Okay, and then we think that might be the best model, but we can figure this out by saying, well, what if this is a linear correlation? So if this linear, does it fit better? Does the exponential equation fit better? So to find it out, we go back to our stat program. Let's go back to the stats. Except this time we're going to do a calculation. We're not going to do the linear regression. We're going to do the exponential regression, which is 0. Okay, so do that one. And so I'll hit that linear regression there. Okay, and again, same thing, go through all this. And this gives us the linear expression, so a times b raised up to the x power. So our equation here is going to be 301.39 1.39 times 1.06 and the power of x. And then our regression here is 0.996. Well, 0.996 is just 1, round up to 1. So I'm going to put this over here so I know it'll round up to 996, rounds up to 1. And so this is a much better regression than this one is, because this one's perfect or almost perfect, and this one is 0.97, so it's not quite perfect. So this is a better regression. So the exponential equation will fit the model, fit the data better on a curve than it will a straight line. And so we're going to use that equation for this bottom one. So we're going to use this bottom equation. We're going to put 42 in. So we'll clear this. We're going to take this 301.39 times 1.06, and the power is going to be 42 years right there. So 42 years, and we get 3483.17. And that's how you do linear and exponential regressions. Okay? Follow your instructions on your sheet and do this assignment on Canvas.